Back in 2015, we put together a fun open source project called the Dual Axis Solar Tracker. This project used laser cut wood, a couple of servos, and some standard Arduino parts to make a fun solar tracker. Nothing too fancy, just a nicely refined version of some other projects. However, the downside of this project was this massive ball of wires that people had to put together to get the electronics to work. This caused a lot of headaches for us, for people who tried to make the project, and also required a whole lot of us sending emails back to people saying, I have no idea what you did, it should work the way you made it. Eventually we decided to remake the entire project to make the entire thing more streamlined, and first and foremost it required us to put together a custom Arduino shield and a custom sensor holder. That plus a few other tweaks made this project a whole lot easier to make, as well as cut down on customer support emails we got. And we're going to show you today how to make a fun version 2 of our dual axis solar tracker. We kept all the same fun design elements people liked about version 1 and put those into version 2. It's still 100% open source. You can use our open source design files to make your own from scratch, or you can buy one of the kits that we sell. We have a lot of people who do both. You don't have to buy anything from us. The entire thing is controlled with an Arduino and 4 light detecting resistors. The code is simple enough people can tweak it or change it around or write their own code for it. Besides a few minor tweaks to the wood, the biggest change we did was making our own custom PCBs, one for a sensor holder and one for an Arduino shield. This made everything so much easier on our end, makes things cleaner and more efficient, and also it's about the same cost overall for people who want to make it on their own and use our open source files. If you want to, you can buy a kit from us. Or you can take the files we have available and remix them, do your own thing with them, or just get them made up from Oshpark or somewhere else. It's pretty quick and easy to do, just takes a couple weeks and a little bit of soldering to get those guys in place. In general, you need 2 metal gear servos, 9G in size, some ribbon cable, the 2 shields, and Arduino Uno. All things that are pretty easy to get and fairly inexpensive to find. You can also throw a solar cell into the mix if you want, but that's not necessary. We're using a laser cutter to make all these components. You could also use a CNC machine, and I've had some people send me photos and videos of this project made out of cardboard or foam board. I've seen people hand cut this before, and it's pretty darn effective. But otherwise, our laser cut files are also on our GitHub. You can just, literally any laser cutter from a university or library will work just fine. 1/8 inch wood and 1/4 inch wood. Stay away from acrylic. First thing you want to do is to use the large 1/4 inch servo holder to screw one of the servos into. Use a couple of those screws that came with the servo you purchased to screw them in from the back side. Make sure they're in there nice and tight and that your servo isn't going to come loose. We use a whole lot of 832 size screws and a 3/4 inch length to make this entire project. Use 4 of those screws and nut sets to get these 4 legs into place. Screw them in loosely first and then attach them to the base and use 4 more screws and nuts to screw it all together. Once that's done, tighten up all the screws and you have the entire bottom third of your project done. We also highly recommend using 4 rubber feet or some other thing to stick on the bottom of your project. Otherwise, those screws might dig into whatever surface you put it onto and scrape things up. Use your second servo and attach it to the other servo mount. Same thing, attach from the backside with 2 of those screws that came with your servo. You can put together the entire center of the project right now if you want to, but there's no screws to hold it together. But here it is all put together loosely. You can put it together later when you attach it to the rest of the project. The single number 1 most annoying thing about this entire project is using small number 2 wood screws to screw the servo horn onto the wood. We've got to do this for both the wing and the round circle piece you see in the background. It really helps to use a screwdriver with a magnetic tip. It also helps to use a smaller screwdriver and slightly drill out that hole that you're trying to make in the servo horn a little bit ahead of time. Then you won't break it as easily. However, if you do break a servo horn, you have extra. It's not that big of a deal. You can now attach that centerpiece you loosely put together earlier to this wooden platform. Use 4 of those 832 screws and 3/4 inch lengths to screw it into place. You can't do it backwards because we didn't make it symmetrical, so there's only one way to go in there, which is great. We need to home the servo so that we put the parts on in the right spot when we screw it all together. So take one of the other servo horns you have, put it on your lower horizontal servo, and turn it all the way counterclockwise until it stops. And then just take it away and be done with it. Place your centerpiece on so that it's kind of lined up with that bottom right leg. This is the furthest right you want your project to go. You can probably go a little bit more counterclockwise to about that spot, but I wouldn't go past that, otherwise run into the issue of cables not reaching far enough or things hitting the Arduino. But then once you have that in place, you're going to screw in the servo to the horn using that extra little tiny screw that came with your servo. We're going to screw the sensor holder into the faceplate using a 1/2-inch length screw. You can go longer, but 1/2 inch is all you really need there. Don't do it very tight, do it loosely to start with, because we're going to put some other stuff on top of it in a moment. We've got these 2 dividers that we're going to be using to keep the light from hitting all the sensors at once. This is necessary for the project. I mean, you could mount the sensors independently onto each of the 4 corners of this project, but this little sensor holder makes things easy. We're going to use 2 832 screws at 3/4 inch length to keep this in place from the backside, but then just tighten it all up and you're good to go. Now take those 2 wings and hook them to the 2 bottom sides of the face. You want the one with the servo horn to be on the left side with the servo horn facing in. Use 4 screws to hold them all down and tighten them up. Now you want to hook the face to the rest of the project. First, you want to home that other servo, and you want to move that vertical servo all the way clockwise. The first one was counterclockwise, this is clockwise. Now we're just going to pop that onto the servo. We're going to use a screw to hold it in place. We're going to use a very long 832-inch screw, about 1.5 to 2 inches in length, to then make a nice counter brace on the right side. Simple and easy to do. You can use a screw to hold that together, but yeah, just stick it all together and you're done with the project. Now is a really good time to check to make sure that your servo motion isn't running parts into other parts. Move that vertical face forward all the way, make sure it's not smacking into the wood, and move the horizontal servo all the way to the left to make sure things aren't hitting anything else. If you do, then you're having problems, but there should be natural stops in how far the servo can move. We're going to hold the Arduino on with 2 M3 screws coming from the bottom or the top. We give you 4 screw holes, you don't need to use all 4. After that, attach the shield and start wiring things together. Everything is clearly labeled on the board as well as the sensor board, so just match things up when it comes to the sensors and plug your servos in the right spot. If things aren't moving properly, double check. There's a good chance your servo may be in the wrong plug, or one of your sensors is not hooked up properly, or the cables are loose. But that's the worst you have to worry about when it comes to electronics. Much easier than that darn bundle of wires we used to have people do. If you want to use a small solar cell, you can also use a small LED voltmeter. We even made a little voltmeter mount for things. Then you just wire those 2 things together using wire nuts or solder them together, and you should be able to get a voltage output from your solar cell. Something we include in our kit so there's some feedback, but otherwise it's not a necessary thing to have, but it's just kind of fun to get some data readings from your project. Before the project will work, you'll have to upload the code to the Arduino. Use any USB computer and copy and paste the code we have at our GitHub repo into the Arduino software. You can change the sensitivity of the sensors via the code. You can also change limits for the servos within the code as well. It's all clearly labeled and pretty easy to figure out, or write your own code. That's another good way of doing it, and some people love writing their own code, but we have very simple code there for you to use. It's pretty straightforward to understand. I keep mentioning over and over again, this is a 100% open source project. You can find the links to the code, the PCB files, and the laser cut files below. You'll also find a link to our website, browndoggadgets.com, where we sell this project. Complete the way you see it right here, all the PCB parts pre-soldered, all the stuff laser cut out. People buying kits from us help us go to teaching conferences, help us make new projects, and help pay for new equipment around our office. We hope you had a fun time learning about this project. If you make some cool new version or modify it or improve it, please let us know. Please post a video. Keep this thing 100% open source, and we hope people remix it and change things and do really cool variations with it, because every time someone changes things, it makes it better for the rest of us. Good luck and have a fun time building.